Hello, my name is Slavo Petric. In this video I will tell you what ECSS PUS Service 13 is and how to use it in PUSopen framework. PUS Service 13, or PUS 13 as we call it, is used to uplink and downlink large data. So let's say that the sender, your payload computer, wants to send processed image data to the ground station. The PUS 13 sends an initial telemetry packet, TM13.1, that contains the first chunk of your imaging data. Then it sends a number of intermediate packets, TM13.2, and then the final packet, TM13.3, with the last chunk of data. It may not be the full size of the chunk, it's just the last bytes of your dataset. In the PUSopen configuration file, you can define what will be the size of each chunk of data. A similar sequence then exists for large data uplink. When you want to uplink, let's say, a command set to your satellite to tell the computer what to do until the next communication session. In this demo, the server uses PUS Service 13 to send test data from the buffer that we define to the client. The client will then simply print out the received data. So let's put together the sending side, the server side. We'll start as usual with the header files. So we will include PUSopen.h, which is the only header file that you really need to include from the PUSopen framework, because internally it includes all the other header files that are necessary. Then we will define our main function and the test data that we will send over from the server to the client over the TCP socket. So in this demo it's a TCP socket, but indeed in the real application it will be either a data bus between your subsystems on board, or it will be then the radio between the satellite and the ground station. So here we have a transmission buffer. We will initialize the server. This is, as I said, only for the purpose of this demo. In the real life we will probably initialize the data bus or the radio here. Now, the first really important thing is to initialize the PUSopen stack, and it needs to be initialized in layers. So we initialize the lowest layer, the encoding layer, then we initialize the packet layer, and then the PUS 13 service itself. Now, to trigger the data downlink through the PUS Service 13, the only thing that you need to do is to call one function, and that function is called PUS13 downlink. That's the only function that you need to call. We define the destination APID. We need to define the data and the length of the data that we are sending, and then a sequence ID. The sequence ID will be added to each telemetry packet of PUS13. And then the next thing that we will do, we will trigger the PUS Service 13 until all the packets are done. So we will do that in a loop. And that's here. So until the downlink is done, we will be triggering PUS Service 13, we will be generating the frames and sending them over to the client side. And in between those we will sleep for 100 milliseconds here. And then we will finish the server code with closing the server and then closing the main function. Okay, so this is the sending part. So again, we have our test data here, we have transmission buffer here, we are initializing the TCP socket, but as I said, in your case it will be probably initializing of data bus. We are initiating the PUS Service 13 downlink, and we are defining which data we will send and a length of data, and then a sequence ID which will be added into each packet. And then we have the main loop, which is triggering the PUS Service 13 for each packet that will be generated. We will be generating the frames and then sending the resulting byte stream over to the client side. And then we are closing the server here. Okay, so this is the server side or the sending side. And then we have client side here. Again, we will start with the header files. The only file that you need to include PUSopen.h, as in the case of the server. We will start here with the main function. Okay, and then again we open the socket for our communication. initialization of the PUSopen stack again in a layers, and in this case we will initialize again the FES layer, the lowest one, the encoding layer, then the packet layer, PUS user, which is actually receiving the telemetry from the server and then processing that telemetry. I will show that to you in a second. And then PUS service 1, which is validating the incoming packets. So how the receiving side will work is we will define a loop here, which will be our main loop, which will wait for the data coming from the server. We will accept the data. So whatever byte stream will come from the server, we will feed it from the bottom into the stack, and then we will trigger the packet layer to recognize the packets in the byte stream, and then we will trigger PUS1, and we will do that in the loop until we have all of the packets received. So we will see how it works in a minute. Let me just finish the main function. And then one more thing that we need to do actually is when we are receiving the packets, we need to define our hook function, which will be called whenever the packet is received. So whenever PUSopen receives the full packet, it will call this hook function, where we can then define what will happen with that packet. And the only thing that we will do in this demo is that we will print out which packet has been received, its service, subservice, destination ID, and then the data which are in the payload. Okay, so this was the receiving side, and now let's try to build both the server and the client application. Okay, so let's call our build script. Build process went okay, and we can see that in the first step we are translating our configuration, the XML configuration, into the C code for both the client and for the server, and then we are actually compiling and building the client and the server applications. Okay, so now let's do the demo. Okay, so we will first run our server application, and then we run our client.exe 127.0.1, and here we can see the result. Once the client connected to the server sent over telemetry packet 13.1, the first chunk of the data, and we can see that the sequence ID was 1, and then we can see the packet sequence 1, 2, 3, and 4, and then there was the first chunk of the data, and then it sent 2 telemetry packets 13.2, and then the last chunk of the data, 9 bytes, with the last packet of the sequence. So this is how you can use PUS service 13 in the PUSopen for downlink. The size of the transferred data is only limited by the amount of memory that you have available. And as I said, the similar procedure exists for the uplink of the data in PUSopen. We want to keep it simple for you. You've seen it. It's about 10 lines of code on the sending side and 10 lines of code on the receiving side. It's simple, but it's proven. PUSopen has a space heritage. It worked for different missions. Teams have used PUSopen in space and as a tool for prototyping and testing their software on the ground. We provide training for your team and tell you how exactly we comply with the space software and space communication standards. Thank you for watching. Visit us at PUSopen.com and do not hesitate to email us for a quick check. Have a great day.